Hello everyone. You've probably heard that it's really hot this year, and it seems like every week there's a new record high temperature somewhere in the world. But is it actually getting hotter? Are we just having a freakishly hot summer, or are things getting generally warmer for good? In this episode, we will have a look at whether it's actually getting hotter and why that matters. It's mid-July and you're watching this report. Whether it's getting hotter or not depends on how you measure it. There are various different ways to quantify the temperature of the planet. The most common one is probably the so-called global average surface temperature, which is the average temperature of the Earth's surface measured at 2 meters above the ground. This sounds pretty straightforward, but actually it's a bit more complicated than that. The reason is that there are very few places on the Earth where someone can walk around with a thermometer in the shade and measure the temperature. It's mostly done with weather balloons, satellites, and ships. So, to calculate the global average temperature, you first need to take all these different measurements and convert them into a common unit and then average them together. Because of course, if you mix temperatures that are measured in Fahrenheit with those that are measured in Celsius, you get an error. And also the temperature on a ship is somewhat different from the temperature in the air, because water has a higher heat capacity than air, and thus heats up and cools down more slowly. That's why you can safely ignore thermometers in hot springs and all. Anyway, after all these corrections have been applied, scientists found that the current global average temperature is about 17 degrees Celsius, which is 63 degrees Fahrenheit for our American friends. But wait a second, doesn't that mean that the entire planet is at the same temperature? Well, not really. You see, the atmosphere and oceans absorb a lot of energy before they start to heat up. The oceans, in particular, absorb about 90% of excess energy and 93% of excess heat. That's why the ocean temperature is much more relevant when talking about global warming than the air temperature. In any case, the global average surface temperature is only one way to quantify the temperature of the planet. Another popular one is the energy balance of the Earth. This is basically the sum of all incoming and outgoing energy flows. If the incoming energy exceeds the outgoing energy, then the Earth heats up. The energy balance can be split into the energy balance of the atmosphere and the energy balance of the ocean separately. For the atmosphere, there are relatively few measurements available, so the numbers are somewhat uncertain. But according to a recent assessment from NASA, the net incoming radiation in the atmosphere was 4.6 watts per square meter higher than the outgoing radiation in 2022. The energy imbalance of the oceans, on the other hand, is much better documented. Between 1991 and 2020, the oceans absorbed 0.88 watts per square meter more energy than they emitted. These two numbers don't seem to add up though. Where does the remaining 3.72 watts per square meter go? Well, it's not missing. It's included in the global average temperature. The point is that both the increase in global average temperature and the energy imbalance are measures for the same thing, namely the energy that's currently missing from the Earth's system. They just use different units. 1 watt per square meter is a flux, whereas the global average temperature is a stock variable. The relationship between the two is that the change of the stock variable is equal to the flow. So in other words, the energy imbalance tells us how fast the Earth is heating up, and at the moment, it's heating up very quickly. Both the global average temperature and the energy balance have increased significantly since the 1970s. The global average temperature is currently about 1 degree higher than in 1971, but the energy imbalance is 20 times higher. Actually, to be precise, this should say 20 times higher than in the 1960s. But according to some studies, the energy imbalance didn't really increase until the 1970s. If we look at the energy balance in more detail, we find that the energy coming from the sun hasn't changed much. The total energy that reaches the Earth's surface is roughly the same as it was 50 years ago. On the right side of the equation, the energy that leaves the Earth's system has also remained fairly constant. However, on the left side, the energy that's trapped by greenhouse gases has increased. In other words, more energy is absorbed by the atmosphere and oceans and thus can't escape anymore. This increase in trapped energy is due to the increase in greenhouse gas concentrations. According to the IPCC, the main cause for the increase in CO2 levels is the burning of fossil fuels. Other human-made greenhouse gases such as methane, nitrous oxide, and fluorinated gases have increased even more. In 2022, the level of carbon dioxide in the atmosphere was about 51% higher than it had been in 1971. Methane levels were 84% higher and the other gases were 205% higher. So yes, overall, the planet is indeed getting hotter, but that's just half of the story. Not all regions of the globe are affected equally. Some areas have warmed faster than others, and some have even cooled. Globally, the temperature increase is largest in the Arctic. It's also particularly pronounced over land and at night. We're really feeling the effects of rising global temperatures, right? Ice sheets and glaciers are melting away, and sea levels are creeping up, which is kind of scary when you think about it. Summers are getting hotter, and we're seeing more droughts, heat waves, and wildfires than ever before. It's like Mother Nature is throwing a tantrum. You've probably come across headlines like these in the news, and honestly, they're hard to ignore. Just look at places like California, where wildfires have become a yearly nightmare. Or think about how coastal cities are having to deal with flooding that's only getting worse. It's a wild ride, and we all need to pay attention. But interestingly enough, while the energy imbalance is increasing, the rate of temperature increase has actually decreased. That's because most of the extra energy goes into the oceans, and the oceans have a much higher heat capacity than the atmosphere. As a consequence, the ocean temperatures are rising much faster than the air temperatures. Currently, the oceans absorb about 90% of the excess energy, and only about 10% goes into the atmosphere. The problem is that this number might decrease in the future. That's because, as the climate continues to warm, the temperature difference between the oceans and the atmosphere decreases, which makes it less likely that the oceans absorb the excess energy. According to some models, the energy transfer from the atmosphere to the oceans could decline from 20 to 40% by 2100. That means that if the current trend continues, the oceans will eventually stop absorbing most of the excess energy, and instead, the atmosphere will heat up. As a consequence, the rate of temperature increase would accelerate. How quickly this might happen is uncertain, but according to a paper from 2021, the transition could occur as soon as by the end of this century. Another issue is that while the global average temperature and the energy balance tell us something about the average situation, they don't say anything about extreme events. Climate scientists expect that the frequency of extreme temperature events will continue to increase. What exactly counts as an extreme event depends on the region. In some parts of the world, for example, in Central Europe, summers are already extremely hot, but winters are still rather mild. In other parts of the world, however, such as the central United States, winters are getting much colder. In fact, it's not only the average temperatures that are rising, but also the frequency of both very low and very high temperatures. Now, I don't want to give the impression that I'm some kind of expert on the topic. In fact, I'm not. I'm just a science communicator who likes to read papers during his summer holiday. But if you want to learn more about climate change, I can recommend a course that's currently running on brilliant.org. Brilliant is an amazing tool if you want to learn more about science, computer science, or mathematics. Their courses are interactive, so you can work through them at your own pace and at any time. The course that's currently running on brilliant.org is Introduction to Climate Change. It covers everything from basic physics to climate feedbacks, radiative forcing, and climate sensitivity. Thanks for watching. See you tomorrow.